And good evening, everyone. It's September 3rd, 2017. We're going to talk about Hurricane Irma. What's going on with that? And of course, all over social media, we're seeing things about it, and it's creating a little bit of confusion. And it's a lot driven by the fact that we just had Harvey hit the southeast Texas coast and the impacts that Harvey had. And then there's also people on social media that are sharing things that shouldn't be shared, especially at this time range, and they don't really know what they're talking about. And it's just creating a lot of confusion and a lot of misinformation going around right now. So creating this video just to try to help break things down a little bit and talk about what we know and what we don't know going forward here and the uncertainty with Irma's future here. Right now, this is Sunday evening, the 5 p.m. advisory from the Hurricane Center. Winds 150 miles an hour. That does make it a Category 3 hurricane. Looking pretty healthy, and it's moving off to the west at 14 miles an hour. And if we take a look at the Hurricane Center's track, it dives down to the southwest and then makes a west-northwest turn and eventually ends up in the Bahamas by the end of the week as a Category 4 hurricane. And that's another weather story that could develop, is a Category 4 hurricane impacting the Bahamas. And the models are actually slowing Irma down as it passes through. So it could be a little bit of a sustained Category 4 conditions for a day or two across the Bahamas, which, of course, when your community is entirely islands, that's not exactly a great thing. But I also mentioned in the advisory that the movement was to the west, and the initial track is to the south and west, and that's what the models are showing as well. And this is from a little earlier today. If we look at where Irma is relative to the track that the models have been showing, it's actually a little bit further north. Now this is important because if Irma stays further north, the chances of it actually recurving out to sea are actually a little higher than if it were to take a more southerly track. That's a little rule of thumb in Atlantic hurricanes. So that's something we're going to keep a close eye on too, is if Irma's track continues to stay further north than guidance, we'll probably start to see a shift in the models towards a more recurving solution. But for now, we still have to watch it very closely. Now, I'll step back in time to the other night. This is an image that comes off the GFS model, and there's a point I want to make about this. The GFS model was just upgraded, and it has some flaws. Hashtag Go American Weather Modeling, right? One of those flaws, though, is it's throwing ridiculously stupid intensity forecasts out on these hurricanes that it develops. So this is a Category 4 hurricane sitting over Delmarva that the GFS put out. This would be catastrophic to everyone basically from Norfolk, Virginia, all the way up to New England, with horrible storm surge, winds that would be, over 130 miles an hour. So you can already get an idea of the impacts. I mean, we had Sandy, which was 70 to 75 mile an hour winds spread out over a wide period, and that did a lot of damage to New England. This would be catastrophic. It's not going to happen, though, and I'll talk about why in just a second. But if you know about the GFS and all of its flaws, you can kind of turn this into more of a comedy entertainment image rather than something that's really scary. If we look at the sea surface temperatures across the Atlantic right now, you can see plenty of warm water. 26 degrees Celsius is the threshold for tropical systems and sustaining their development. There's plenty of warm water in Irma's future here, so that's why we have the intensity continuing to increase. But if we look up the East Coast, notice how the water temperatures really start to drop off as we go north. The yellow and green line is basically that border of tropical system development and water that's too cold. Now you can kind of make out the Gulf Stream here too, so that does kind of enhance this a little bit going up the East Coast. But overall, the water temperatures decrease as you move further north. And that's going to weaken a system as it moves up the coast. The other thing we can look at is how deep that warm water is, because what happens when a hurricane moves over the water, it upwells a lot of that colder water that's below the surface, and it cools off the surface temperatures of the water. So if that warm water is really deep, it can actually help in continuing to develop and sustain the intensity or increase the intensity of a tropical system. And that water is very warm, very deep in Irma's short-term future as it passes up into the Bahamas. But notice again, as you move north, that water temperature drops off, and the thickness of that warm water drops significantly as well. So again, this is why we'll never have a Category 4 hurricane come up the East Coast and make landfall in the mid-Atlantic. It's just not going to happen. The water temperatures would not support that, and you drop off the water temperatures even just a couple of degrees, and that thing will drop in intensity very rapidly. So sea surface temperatures and maintaining that minimum threshold very important. So anyway, moving on. Here's what today's model run showed, the Sunday afternoon runs. The GFS continued its landfall solution, no longer in the mid-Atlantic, but did make landfall kind of South Carolina, North Carolina area, and then moves it inland and weakens it very rapidly, as you would expect. Still very strong. It did have an erroneous intensity. It was basically a superstorm making landfall in South Carolina. That's probably wrong. The track is definitely a potential solution, but we're not going to have a superstorm make landfall in South Carolina. If we take a look at the GFS ensembles, and I'll explain the ensembles in just a second, there's a wide spread among them. You can see they go from basically Florida to a recurving solution. So that tells me there's a lot of uncertainty with the forecast. The European model this afternoon recurved the storm out to sea. Did pass it close to Florida and parts of the southeastern U.S., but it stayed out to sea enough that the impacts would be minimized. But again, the European ensembles, a very wide range. I mean, this goes from Louisiana to a recurving solution. So uncertainty is very high in the 7 to 10 day range. And basically what an ensemble is we take the regular model. So for example, the European ensemble is made up of 51 different members. It's basically you take the European model, you tweak the initial starting condition, and you rerun the model, and it produces a slightly different solution. And then you can use that for comparison to see how erroneous a solution could be. And it's very good for diagnosing uncertainty, especially in the long range. So why do we have all this uncertainty, and why do we have the track differences between the models? Well, it all has to do with the upper level pattern as we get into next weekend. Here's a look at the GFS model, and what it has is, here's Irma down in the Bahamas right here, and then there's a trough over the eastern U.S. that's actually from a front that'll move through mid to late week this week, so we will get some rain from that. But if we look, there's a ridge over the North Atlantic and there's a ridge over central Canada. This ridge over central Canada is basically trying to connect with this ridge over the North Atlantic. This ridge basically collapses, and this trough over the East U.S. basically collapses. And you get this big ridge over the Canadian Maritimes and eastern Canada. And what that does is basically block Irma from making that recurve out to sea, because it would basically then be driving an area of low pressure straight into a high, and that's not going to happen. So what Irma is going to try to do is go around the ridge, and it's actually being aided by another area of upper level disturbance that's actually helping to pull Irma into the coast, kind of like what happened with Sandy, and it's going to try to go up and around the ridge. So that's why the GFS is recurving Irma into the U.S. Whereas the European, this ridge is a little bit stronger over the North Atlantic, and it's going to continue to move off towards the east. It's not going to break down. That allows this trough to exit and positions this ridge that's over Canada in an ideal position that actually blocks Irma from coming into the U.S. Again, you can't drive an area of low pressure straight into a high. And again, the result is that Irma recurves away out to sea. So that's where the track differences are coming in. I personally lean more towards the European model. Of course, it has the better track record. But any of these solutions are still possible, and these things are very difficult to try to discern and figure out at this kind of time range. So, by about midweek, we'll definitely have a better handle on what's going to happen, and we'll know more. So the uncertainty is still very high right now. So it's not time to worry, but it is something to definitely keep an eye on as we go forward here over the next couple of days. So that's what is going on with Irma right now. Hopefully this kind of helps to pull back a little bit of the concern, and we'll continue to keep an eye on it as we go through the next couple of days. Have a great evening.